Hello, my name is Jordan Bruel. I am a third-year computing science student at the University of Alberta in the CANOSP program working on Review Board. My project is Go-DiffX, a Go module for creating and parsing DiffX files. If you're unfamiliar with DiffX, it's essentially a new standard for adding metadata to unified diffs. I have a couple of minor functions to show off first, and then there's the first big step towards working with DiffX files for metadata, get unified diff hunks. The first thing is just a new encoding function that works much like the encode function in Python. Here I am just encoding a $sign ending, so it carriage return a new line, and you can see how it changes depending on which encoding I specify. The next functions are both for new lines. The first function here just encodes a new line without a byte order mark. So as you can see, I have one for UTF-8, UTF-16, and UTF-32. You can also do different versions like little endian or big endian, and those are all options. The next function I have is guess new line for type. And what we'll try and do is we'll try to guess a line ending given some byte buffer, and it will assume it is a Unix line ending if it's unsure. And as you can see, you can do it with just regular UTF-8 strings, and you can also choose different ones like UTF-16, and you also have the option of doing UTF-32 and other variants as well. The final part here is the get unified diff hunks file function, which takes a list of byte buffers based on a DiffX file and parses them while pulling out the features of each hunk. So as you can see here, I have a bunch of different byte buffers, and these are all going to be lines that you would expect to see in a DiffX file, and over here I've printed them out along with their associated line numbers. Now in this example file here, we have two different hunks that you can tell by these different headers, and I'll quickly go through what the parts of these headers represent. The first number here is the one-base start line number for the changes for this hunk in the original file. The second number is the number of lines contained in this hunk in the original file. And then after here, this 12 would represent the start line for the modified file in the hunk, and 10 is the number of lines in this hunk as well. And so as you can see, we can look and extract a bunch of data like the original starting line that is zero-based. So in this case, it would be 9 would be the zero-based. We can also get the number of lines changed. We can also see in the modified version that this start line would now be 11 since we're assuming that it's 12 instead. And we can get information like what's the first line changed in the original, and we could see it's 9, 10, 11, 12, just like it says here. That's the same as last line. And again, if you were to look at the modified version, we have 11, 12, 13, and then 14 is our first changed, and then 15, 16, 17 is our last one, just like here. We can also get some context as well. So here we can see that context for the first hunk is this def foo self, and it includes all of that in our context. And as well, you can see the same information is found for our second hunk. Finally, there's some information about the overall hunks that we've collected, such as the total number of processed lines, which is 20, the number of total inserts we have, and the number of total deletes. That's all I have today to show. Thank you so much for watching, and I hope you have a great day.